did you get me the right computer? Well, maybe. Or it's on that one, that one. It happens. And so this also works really well if you have to go after files that have been deleted. Because in unallocated space, if it's fragmented, you're not going to get the full hash. And so by breaking down the files, it gives us a little better chance if we have to go to unallocated, because sometimes they don't tell you for a month, a week. It's showing up in David Cohen's lab about 2 years later saying, we think this file is there. Can you find it? And so what I've done is I've started breaking down malware blocks into clusters and sectors to figure out if the file is there. Dmitrys had a great talk this week, and he talked about being able to memorize what the code block looked like. And I'm like, I can't remember all that code, but what I started doing is after this came out, I'm like, okay, they've identified that the Reagan module was related to the QRT module, keylogger. And so I'm like, I wonder if this can be found in other samples that are out there on like virus, share, malware. Are there other ones that aren't identified? And so I started running it through, and I realized that my process didn't scale. I was using SQLite text files. I needed something bigger to be able to go out and find the blocks. And so about that time, Bruce Allen with the Navy Postgraduate School started doing large quantities of update to the HashDB. It's a back-end database that's hooked into bulk extractor. It's pretty cool because not only can you use the speed and performance of bulk extractor to go out and create your hash libraries, you also can start scanning against it. And what bulk extractor does is it outputs an identified block TXT file that contains the hash and the number of ones that match. When you run it back through HashDB, then you can run a scan expanded, and it's going to come back and say these samples are related based on this hash block, and you can start looking. It's a way to quickly identify malicious blocks that are related, because my memory is not as good as Dmitrys. And so when we flip over here, who has the biggest collection of malware that's publicly available without having access? FireShare. That lone administrator, when you go through, and if you break down the malware into clusters, it's going to have 1.2 billion, or if you break it down into sectors, there's about 9.6 billion. I've updated this since then, but that's a lot of malware. I mean, we can ask for billions, but you have to be able to use it. And so what are the characteristics of a block? Bulk extractor, by default, will go through and flag if it's all white space. It'll flag if it's partial. It flags if it's all one character. But when we start looking at it, I was looking at one of the malware families, and all of a sudden this block flagged, and it had 16,000 matches. I'm like, okay, something's way wrong. And what it ended up being was a block with just a single letter A. That's a very low entropy. The characteristic of that block isn't going to match very well. Now, if you have a block with the numbers 55AA, to digital investigators, that has a specific meaning. For some low entropy blocks, that's going to be huge, because your human analysis is always great. You can depend on machine learning and different parts for a certain aspect, but it always comes back to human analysis once you can crunch through all the data. And so the cool part is I started running this against hotel computers, because hotel computers tend to be infected. And I started to run into large quantities of false positives when I was doing this. So I ended up building my own hash set out of a cluster size, and I put it out there and I'm running it, and it's reduced my cluster ones by about 1 million, about a third the size. And a little bit later, NIST came out and released block sets of the entire NSRL list. Long as the file size was 512 or bigger, they actually released this. It's about 107 gigs to download. It uncompresses to about 500 gigs. And when you build your database, you end up with about 240. But when you run this against the virus share, what it does is it reduces it by about 25%. So there's a lot of reused code in there. Now, the structure isn't the most friendly, but it works. It's just a flat text file, and it creates a really neat structure. And so if you ever have time to download it, it's there. The other thing is we've looked at this works against memory, this works against the disk. James Carter talked about winning in triage. If I can move my detection out from the host to the network, it's great. Anybody played with Bro 2.4 release? they did a huge amount of work with the file analyzer where they can restructure the files even if they're out of order. And so you start running this against your PCAPs, your networks, and you can start identifying blocks at the network level. So now we have the host, we have the network, and we also can do binary analysis. I wrote a bulk extractor module for Viper because I got tired of doing it manually and using spreadsheets and typing. And so I wrote a plugin or module for Viper. And what it does is it'll go through, match the blocks, and because the human analysis is always more valuable, you can pull up the hex view and see, okay, is this just letter A, or do I really care? And then you can list out which samples have that matching block in. Now, it's not going to replace SSDeep unless you're in unallocated space. If the file is there, great, but otherwise this is a quick way to identify. And so, if you want more updates, follow me on the file blocks and I'll be posting more.